Welcome to math class, where today we're going to be converting point slope form into slope intercept form. To complete these notes, you will need the following notes page provided in class, and you will need to have your testing version of Desmos open in order to check our solution. Okay, so converting point slope form equations into slope intercept form, we're going to look at two methods. On the notes, you'll have three methods. We are not going to utilize method 3. It takes a little bit longer. We're going to focus first on method 1, solving for y. So method 1, the solve for y, in other words, this what you're doing is just isolating the y variable. This method involves substituting one known point into point slope formula, then solve for y to put the equation into slope intercept form. So you have y minus y1 equals m, which is your slope, times x minus x1. And the first thing you want to do is to zero out your y1 by adding y1 to both sides. This will give us the following form. Y equals m times x minus x1 plus y1. Next, you distribute your slope. As you distribute, remember distribute means to multiply. So we're going to have y equals m times x minus m times x1 plus y1. It is important to note that x1 and x are not the same thing. x1 and y1 have values. So in this problem here, our goal is to recognize this part right here. We're going to take negative m times x1 plus y1. And what that's going to do is that's going to give us our b, our y-intercept. So the final part of this, the y-intercept, is just simply negative m times x1 plus y1. So let's look at some examples. This first example, example 1, we are given negative 3, 8 with a slope of negative 5/3. So let's write this out in point slope form. Y minus 8, because remember you take the opposite of your values here. So we're going to use a negative 8 and a positive 3 or a plus 3. Y minus 8 equals negative 5/3 x plus 3. Okay, first thing, we're going to add 8 to both sides. We're going to end up with this part of it being zeroed out. We're going to have negative 5/3 of x plus 3 plus 8. Next, we're going to distribute. So we're going to have negative 5/3 x, and then negative 5/3 times 3 is going to cause the 3's to cancel, leaving us with minus 5, and then we'll still have plus 8. The last part is to combine the negative 5 and the 8. When we combine those, we're going to get 3. So our final equation is y equals negative 5/3 x plus 3. Why do we want it in slope-intercept form? Well, because we can actually graph the y-intercept of 0, 3, and then using the slope, we can find a second point. So that's our y-intercept, not b. The b value is the 3. So we're going to plot the first point, then using slope, we would find the second point in order to graph it. Example 2. We've been given 5, negative 3 with a slope of 2/3. So first things first, write down the form y minus y1 equals m times x minus x1. We're going to substitute in. we're going to have y plus 3. Again, remind you, it's the opposite of whatever these numbers are. So we're going to have a minus 5 and a plus 3 that we're going to be using equals 2/3 of x minus 5. Okay, next we're going to add, or not add, but we're going to, we're going to add a negative 3 to both sides, or in other words, subtract 3. This will cause this part to 0, leaving us with y equals 2/3 of x minus 5 minus 3. Next, we're going to distribute. So we're going to have 2/3 x minus 2/3 of 5. Okay, we're going to end up with minus 10/3. And then we're subtracting 3. Well, the 3 and the negative 10/3, we would combine these. We're going to have a problem here. We need to turn our 3 into a fraction. So this is going to become 3/1, but to actually combine them, we need a common denominator. So we'll multiply by 3. So this part here ends up going away to make it 9/3. Now we can subtract. We're going to end up with the final form of y equals 2/3 x. Negative 10 minus 9 is minus 19/3. So the y-intercept in this problem is going to be 0, negative 19/3. Last example, we have 0, negative 9 with a slope of negative 7/3. Now, this equation can quickly be written into slope-intercept form. 0, negative 9 is the y-intercept already. Okay, but what we're going to do is we're going to go ahead and just put it into point-slope form. Once we take this, because this equation can just simply be rewritten as y equals negative 7/3 x minus 9. Okay, whatever the values are, that's what we would keep. However, like I said, I want to throw this into point slope form, so we're going to do y minus y1 equals m times x minus x1. Okay, substituting in, we're going to get y plus 9 equals 0. Nope, don't know what I said, 0 for. Negative 7/3 of x minus 0. Plus or minus 0, it doesn't matter. Okay, next I'm going to subtract 9 from both sides. And we're going to be left with y equals negative 7/3 of x minus 0 minus 9. After that, we will distribute. We're going to end up with negative 7/3 x. Negative 7/3 times 0 is just 0, so we can drop it off, minus 9. So as you can see, point slope form versus slope intercept, we still get the same exact equation. This is why we can actually just quickly, whenever we see that we have the y-intercept already, we can just quickly jump into the form that we actually wanted in. What we're going to do is we're going to jump into Desmos here, and I'm going to show this first equation how we could check our solution. So we had in the first one, we have y minus 8 equals negative 5/3 of x plus 3. So we're going to go ahead and type this in. Y minus 8 equals negative 5/3 of x plus 3. Okay. Now, what you should see in Desmos is that you cannot graph this. Let me kind of make this a little bit bigger. You cannot actually graph this function because plotting an implicit equation and inequalities is disabled because we are using the testing version, which you'll notice because I have a green bar and it says EOC in it. What I can do is fix this equation by taking this -8 and go ahead and push it over just like I did when I was solving for y. So I'm going to do the opposite of whatever I have there, take it away, and now I'm going to have an equation. I'm going to have a line drawn on my screen. Then I can check my work. And to do this, I'm going to go ahead and turn this into a dotted line so I can see the actual change because I don't know what color the next line is. But we're going to get y equals -5/3 of x. As you can see, it's already running parallel next to the dotted line. And then we had +3, and now you can see it covers up the line. This is a way that we can use Desmos to check our equations to make sure we came up with the same equation or an equivalent equation. Thank you for watching.